be Miss Limartaida Siahaan from Politeknik Manufaktur Negeri Bangka Belitung, Agronomi, Indonesia. And her presentation is entitled Newly Observed Phenomenon of Lowland Tayu Tea in West Bangka, Indonesia, Soil Chemistry and Bioactive Profiles for Climate Resilient Potential. Please join me in welcoming Ms. Limartaida Siahaan. Ms. Limartaida, could you please open your mic and represent? Thank you.
Okay, guys, can you hear me? Hello?
Yes. We
All
can
right.
hear you.
Okay, I'll start my presentation then. Okay, so first of all, thank you so much for the time and the opportunity to the ISTAFI Symposium 2026. My name is Limartaida Siahaan, and here are the name of my research team. And now I am going to present our research with the title Newly Observed Phenomenon of Lowland Tayu in West Bangka, Indonesia, Soil Chemistry and Bioactive Profile for Climate Resilient Potential. And here is the outline for my today's presentation, and I will directly start from the introduction. Okay, as the research background, as we know that tea is the popular drinks or beverage around the world. Not only because of it tastes, but also because tea contains functional bioactive compounds such as polyphenols, flavonoids, tannin, caffeine, and GABA. And this bioactive compound have the benefit for human health, such as an antioxidants, anti-inflammatory, anti-cancer, and anti-diabetic. And from several studies say that this bioactive content of tea is influenced by various factors such as the type of plant, growth stage, temperature, humidity, light intensity, and other agroecological conditions. And next, I would like to talk about the common variety or common type of tea that usually used by the farmers as the raw material of the tea drink or tea beverage. So there are two types. The first is the Camellia sinensis variety, or known as the Highland tea, and the second is the Assamica variety, or usually known as the Lowland tea. In this presentation, I'd like to talk about the Highland tea, which is the sinensis variety itself. And because it is a highland tea, so there should be the requirement for the agroecological for this kind of tea can be grow well. First, regarding the elevation must be 300 to 2,000 meters above the sea level. And for the temperatures, 18 to 23 degrees Celsius, annual rainfall 1,500 to 2,000 millimeters, relative humidity 80 to 85%, and pH 4.5 to 5.5. However, here in Bangka Belitung, especially in West Bangka Regency, Ketak Village, we have the Tayu tea, or in Indonesia, we call it Teh Tayu. So, based on our observation from the several studies that learn about this Tayu tea, and also from the morphological shape, this Tayu tea is actually belong to the Sinensis variety. However, just like we said before, that usually the elevation of the Sinensis variety is 3,300 to 2,000 meters above the sea level, right? But for the Keta village itself, the elevation only below 50 meters above sea level. So, why does this Tayu tea become a unique tea that needs to be studied and developed? First is because the growing environment. As I talked before that this Tayu tea belong to the Sinensis variety. This is kind of unique because usually the Sinensis variety grow well in the highland areas. However, this Ketap village only lower than 50 meters above sea level. So we assume that there will be different soil characteristic and agroclimate. And also this tea has a high potential for bioactive compound content, because several studies say that abiotic stress reduces yields by up to 65%, but stimulates the synthesis of bioactive compounds, especially from the phenylpropanoid pathway as plant defense mechanism, and also from its social, economic, and cultural values. Based on our interview with the resident or the local member of Katap village, they said that this tea tayu brought by their ancestor from China, and it is a cultural heritage of their ancestor and still used in traditional ceremonies of the Chinese tribe in West Bangka. However, not only in Indonesia, even in Bangka Belitung Island itself, this kind of tea not yet widely known by the resident. And also, its potential for national tea production. Based on the data of our Central Bureau Statistic 2022, it says that Indonesia tea production and export decreased by 4.3% and 5.8% respectively in 2021. And also, this Tayu tea actually can be a potential uh, as a rehabilitative plan for farmer mining land. As we know that tea love the acidic pH soil, and also Bangka Belitung itself, it's the larger tin mining land in Indonesia. So this Tayu tea has the potential for the rehabilitation. And also this Tayu tea is in process of registration as a geographic indications. So it is important to study more about this kind of tea. So our research objective is first to analyze agroecological characteristic, particularly soil fertility in Tayuti cultivation areas of West Bangka, to evaluate the relationship between soil fertility characteristic and bioactive compounds, and to develop an adaptive cultivation model for Tayuti under suboptimal environmental conditions to support product quality and its potential as a geographical indication product. Next, material and method. This research was conducted in 3 local tea gardens in Ketap Village, Jebus District, West Bangka, in September 2025. And for the statistical analysis, we used descriptive, regression, and correlation. Next, for the soil sampling analysis. For the soil sampling analysis, we choose 3 plantation. And every plantation, we choose 3 spots of sampling site, and we also recognize it as the replication. And for the method, we use the composite sampling. And for the laboratory analysis method, for soil pH, we use the electrometry, and organic carbon, we use the spectrophotometry using the Wolke Black method. And then for CEC, we use the ammonium saturation. For total nitrogen, we use titrimetry using the Jadal method. For the available phosphorus, we use Bray2 using the spectrophotometry, and essential potassium, we use the flame photometry. And as the supportive environmental data, especially for climate, we obtain the data from the Indonesian Meteorological, Climatological, and Geophysical Agency. And for the tea leaf sampling and analysis process, just the same for the spot and the replication, just the same with the soil, but we make sure that we took the leaf from the healthy plants. And also for the bioactive substance determination, for the total polyphenols, we use the Folin Shio-Calteo method. For the total flavonoid, we use the spectrophotometry. For the tannin, we use the AOAC method, caffeine Shaw and Zhang method. And for GABA, we use the measurement using the UPLC analysis. Okay. For the result and discussion, first, the characteristic of Tayuti land. This data we obtained from our interview and also our direct observation in the Saketap or Ketap village. For the plantation A, the age of the plant is to 12 years, and plantation B 15 years, and plantation C 150 years. And also here are the data for the harvest frequency, usually 2 until 3 times a month. And then for the fertilization, most of them fertilize for twice a year, but plantation A using the urea, B using the NSL, and plantation C use the combination of them. And for the land use surrounding, the plantation A, near to the oil palm area, near to the coastline as well, and plantation B, within the oil palm plantation, and plantation C, near to the residential area and intercrop with durian. And for the elevation itself, plantation A only located only in 34 meter above sea level, B 35 meter above sea level, and plantation C 33 meter above sea level. And for the chemical and physical characteristic soil, here is the result that we got from our experiment. But based on the literature studies, we know that the pH, total nitrogen, organic C, and exchangeable potassium are still consistent with the characteristic of soil in tea plantation in general, like in India, in Taiwan, and in China. However, the available phosphorus, which is the average the average to 25.82 is actually relatively high. And for the cation exchange capacity or CEC, with the average 3.38 is relatively low. And also we learn from this data that the trend in organic C does not align with the previous studies on other Sinensis tea plantation, which reported that C peaks at 16 to 20 years of age. However, after 35 years, the organic C content in the soil decreases. So it is indicates that environmental factors and management practices of Tayu tea cultivation help to maintain soil carbon reserves. Next characteristic of the agroclimate of Caterpillar Jebus. Here is the literature review that we present in a table, and also here is the climatic data that we obtained from BMKG, our climatic central. The data obtained from September 2024 until September 2025. So basically, based on the literature study, we learned that the annual rainfall of in the Jebus district, which is the location of this original Tayu tea plantation, is very high, which is 4,440. While based on the literature itself, the highly suitable climate, especially rainfall, that good for this Sinensis variety tea in general, only 2,500 until 3,500. So the main environmental limitation also are rainfall, soil temperature, and daily radiation in this Tayu tea plantation. So these climatic conditions suggest that the Tayu tea population has undergone physiological adaptation to environmental stresses, distinct from those of typical subtropical Sinensis. Here is the percent correlation. In here, we can see that there is a positive correlation between total nitrogen and organic carbon. It might be happen because organic carbon is correlated with an indicative of the composition and the diversity of soil microbes, thereby indirectly elucidating the availability of these bacteria that facilitate nitrogen mineralization. And also it obtained that there is a positive correlation between total nitrogen and exchangeable potassium. It might be happen because soil with elevated organic matter content typically exhibit enhanced cation exchange capacity, hence increasing the availability of potassium to plants. We can also see that there is a negative correlation between extensible potassium and available phosphorus. It is likely related to various factors influencing phosphorus availability, such as pH, organic matter content, soil texture, and cation exchange capacity, of all which can alter post-absorption and precipitation. And also we can see here that there is a negative correlation between extensible potassium and flavonoid. It might be happen because apart from enhancing plant resistance to abiotic stress, the presence of potassium also reduces nutrient stress in plants, resulting in diminished synthesis of secondary compounds such as flavonoid, which typically increase as defense adaptation mechanism. And also, we can see that there is a strong positive correlation between,
Could you hear
yeah,
me?
yes,
We're really sorry. We would like to still continue to listen to your presentation, but
Yeah.
since we have a very limited time, we
Mhm.
have to stop right now.
Oh, okay. So yeah, that's the research.
Could
That's
you
the
please,
result from
I'm
my
sorry, yeah, okay.
research. Thank you.
Okay, thank you so much, Ms. Limartaida Siahaan. It's very interesting and insightful presentation. Thank you for your time.
Thank you.
Okay, now we are transitioning to presentation two. We will now proceed to our second presentation. Our next speaker will be Mr. Mohamed Gaukhan Tamalaki from University of Pembangunan Nasional Veteran Yogyakarta, Indonesia. He will present his research titled Development of Sulfur-Activated Biochar Integrated with Soil Microorganisms for Sustainable Post-Mining Land Rehabilitation. Mr. Gaukhan Tamalaki, please represent now. Thank you.
Okay, thank you very much. Good afternoon. Thank you for your opportunity. My name is Mohamed Gaukhan Tamalaki. I am from Master Program Soil Science, Universitas Pembangunan Nasional, Veteran Yogyakarta. I want to explain my research. The title is Development Sulfur-Active Biochar Integrate with Soil Microorganism for Sustainable Post-Mining Land Rehabilitation. This is my uh, research research background. The only problem is post-mining land degradation. I have 3 points. This the global post-mining land crisis. Mining activity damage ecosystem functional, destroy the physical structure of the soil, and trigger the mobility of heavy metal and extreme acid mine drainage. The second is extreme pH and heavy metal. The emergency of the phenomenon of acid mine drainage and high mobility of toxic metal pollutant such as arsenic, cadmium, uranium, and mercury. The last is soil biological deficit, the death of functional microbial population that support soil biogeochemical cycle. This is illustration what the system in the soil. Next, limitation of conventional rehabilitation. I had two two point in this part. The first is single intervention. Conventional reclamation approach generally on a single approach. This separate method is less adaptable to the complexity of the pilot condition and dynamic pollutant stress. Next, toxicity to inoculant. Direct introduction of microbial fertilizer into mine drainage often fail disably without a protective carrier. Functional microbial cell die immediately due to export to heavy metal and extreme acid acidity levels. Next, I have two systems in my study. The first one is internal and external synergy. In the study design, a sulfur-activated biochar-based amendment to address physical, chemical, and biological degradation simultan. I have two. The first one internal activation with pyrolysis technique to develop high structural porosity, followed by gas activation technique, external activation of sulfur dioxide to increase the number of active functional group of sulfonic acid on the surface of the material. Next, I have 3 steps to make biochar modified amendment engineer flow stage. The first one is the first step is pyrolysis, conventional of local biomass, palm cell, or corn cob to control slow pyrolysis to form a stable porous carbon framework. The next step is sulfonation of sulfur dioxide gas. Chemical functional as functionalization of biochar surface using dry sulfur dioxide gas, introducing active organosulfur group to capture metal cation. The last step is microbial inoculation, filling functional microbial phosphor solubilizing bacteria or mycorrhiza into biochar microporous as a safe microbial habit. Next, this is synergy of biological component of the rhizosphere. Microporous structure of modified biochar act as ecological niches. Physical protect space for nitrogen fixing and phosphorus solubilizing microbials. I have three symbiotic function of biochar microbial. The first one is toxic protection bacteria from toxicity of heavy metal contaminant. ESP product help a biosynthesis of extracellular polymeric substance, which stabilize soil aggregate and stabilize heavy metal in the soil. And the last is nutrient cycle, accelerate the provision of macronutrient in the root of pioneer plant. This is a chemical reaction mechanism. In the reactor, uh, detector target is quantification of internal area development microporosity. The last is proximate test, percentage of free water as volatile matter and non-volatile matter and fixed carbon content. This is a hypothesized mechanism and outcome. I have 3 points. The first is material characterization outcome, laboratory verification. The second is soil remediation, chemical and physical restoration. The third is ecological, functional, biological, and vegetation recovery. You can see it, please. Okay, thank you very much. Do you have any question? You can contact me at my email, my contact phone, or my LinkedIn.
Okay, thank you so much, Mr. Mohamed Gaukhan. It was a very insightful presentation.
We will just transition to an on-site for this.
Okay.
Excuse me, John. Speaking here.
Over here.
Yes. Wait, I will just share his PowerPoint. Just a minute. Oh, okay. This is your pointer? Okay, great. Oh, wait. Sorry. And then this one. What's this? Let's try if they can hear you. Please fix so that we will see you. Please fix it. Can you see him?
That's it. Yep.
Okay. Is it working?
Yeah.
Mm. Okay, let me, so they can see. Okay, yeah, I think they can see. Okay, just a minute. Oh, can you hear him? Kindly speak.
Can you hear?
Yeah.
Yes. Start.
Yeah, there's a
Okay, good afternoon, everyone. I'm Ahmed Mahmoud, master's degree student in College of Engineering in NCHU. And today we're going to talk about one of our previous projects, which is Opuntia Ficus-indica powder as a biocoagulant for substance sewage treatment and agricultural water reuse. First of all, I'm going to talk about our agenda for today. It's an introduction and background, methodology, results, analysis, and conclusion. Water is the most important thing in our world, and for the uses of it, we can see that agriculture consumes around 70% of the total fresh water around the world. And for industry, it consumed around 20% of the water, and for domestic use, it consumed around 12%. And water scarcity is a major challenge for our world, and we have to focus about it. On the other hand, we can see the wastewater it takes around 80% of wastewater released to the environment without treatment or without proper treatment. So we have a challenge and we have a solution. So why we don't use wastewater and treat it for the agriculture? This is our motivation for this project. And for this project, we use the Opuntia Ficus-indica or pricky beer, are known as India fig. It's a biomaterial in the industry and in the environment, and we use it for main reasons. First of all, it's a natural and biodegradable material, low cost or almost zero cost, and abundant in dry region. And it's non-toxic and environment friendly. And the main important of it, it's rich in mucilage and polysaccharides, and this advantage make it to make a biocoagulation and fluctuation and absorption and bioadsorption. Our methodology for this water treatment It's divided into four main steps. The first one is preparing the cactus or the OFI by peeling and drying and grinding it into powder. And on the other hand, is the second step is primary filtration. Primary filtration, like the sewage water or the raw sewage water, it passes through a sand filter to remove the suspended clay and material. And the second one is jar test, like sewage water is mixed with the cactus powder and steering at a specific speed and then resting. And the final result will be passed through and secondary sand filter to remove the cactus chlorophyll. This is the real photos from our project in real life. This is the raw sewage water without anything. And after that, this is the initial sand filter. And after bathing, it will be the sewage water after bathing in the initial sand filter. And then preparing the cactus after peeling and extracting the interior parts of it and drying and grinding it into powder and then mixing together and steering at the specific speed. And after resting, this will be our final result and take our bus, like we can take in the middle here, and passing through secondary filter with activated charcoal. And this will be our final result of treated water. Now we're going to talk about the results. Our result is divided into three main categories for water treatment. The first one is water parameters. We can see that the COD and BOD removed by like 99%, and turbidity is removed by 97%, and the TDS removed by 94%. And this was amazing parameters for this water treatment. And the second category is for heavy metals. Heavy metals, we can see that Fe, CD, Zn, aluminum, all of them are removed with amazing percentage of it. And the third one, and the most important of it, is the bacteria removal. We can see that the flux is combined at the surface of it, like in a white flux bacteria here. And we can see that the removal bacteria, like fecal coliform removal and the total coliform removal by 99% of the bacteria. But we can ask that what happened and how it happened and how it could learn. Now we're going to talk and analyze the discussion of that. Here we can see the final result after water treatment and the steering. We can see that the white flux above, this is the bacteria flux, and the other one at the middle is the massive flux below. This is the cactus powder and the total suspended solids that remain at the bottom of it. Under microscope, we can see that before we can see that the controlled sewage water shows that bacteria are moving freely without any conditions or any connections. And after using the cactus, it connected and make a flux and strong flux, which make it a post treatment for massive folication. This is the mechanism under this treatment. We can see that inter-particles bridging mechanism. We can see that the cactus contains a lot of polymers, but it's mixed. So we are make a rapid steering for it and make the polymers stains like chains and long chains without mixing. And then the nature collides with positive sign like move. Okay. Yeah. The positive ions of OFI like collide the adsorption with the negative clay particles and then mix the clay bridging mechanism, and we can see that not moving. Can move to another slide. Oh, it's okay, it's move. This quick video is describing this mechanism, like it's the absorption mechanism, like the negative charge connected to the positive charge and making the bridging mechanism, like it's moving all bacteria and collects the flux together, and we can get finally our clean water. And on the other hand, we can see that other products and chemical products can use for water treatment, like alum, which is aluminum sulfate. But we can compare together with the main difference between our cactus and alum. We can see that the source for cactus is a natural plant, but for alum, it's a chemical, and it has hazard, like because it's higher cost and more hazard health. But the cactus powder is no cost, almost no cost, and non-toxic. And the most disadvantage of alum that it's reduced the pH of the water. But for cactus, it's main sustainable and like minimal change. It will be like 7.5 or 8. And the flux for cactus is more compact and cannot be moved freely. And this make advantages that you can take the clean water in middle without destroying the flux. And our conclusion and future work, we can see that the cactus make an amazing result in water treatment and removes the COD, BOD, TSS, and turbidity. And on the other hand, it removes also the bacteria and make it suitable for agriculture and irrigation process. And for recommendations, we have 3 main recommendations. Use the mucilage extract without making like using technology to extract only mucilage and polysaccharides of it. And we can use the dry machine. We cannot use dry machine and use the sun for it. Like we can dry under the sun for 2 weeks or more, and combine the other coagulants with cactus, and this make like maybe continue or give us a higher result for it. This is the end of our presentation, and thanks for your time. Thank you.
Okay, thank you so much. Thank you so much, Mr. Ahmed. Now we are going to do a joint discussion, Q&A discussion. We are pleased to have all 3 presenters joining us for this discussion. And if you would like to ask a question, please briefly introduce yourself and indicate which speaker your question is directed to. For online participants, you may raise your hand or submit your question through the chat. We are now open the floor for questions.
Okay.
I'm still open. Just
There's 2 questions. We can turn it over to Professor Nichols. There are no questions, Professor. So we can turn it over.
okay, if there are no questions from our online participants, we are going to move the question to Dr. Muhammad Nurkolis. Please join us for the reactors. Thank you.
Hello.
Yes, Professor, begin.
Yes. Okay. Yeah. For the first presenter. Yeah. So I think tea is known tolerate to low soil pH and high exchangeable aluminum. Yeah. So why not you analyze the exchangeable aluminum in your soils? And then also about the major limiting factors, yeah, that affecting the production of the bioactive compound in Tayu tea. Okay. Okay. Yeah.
Okay, should I respond now?
Yes, Miss Limartaida, you can please answer the question.
Oh, okay. Thank you for the question, Mr. Now, about the exchange aluminum, why didn't I analyze it as well? Because we have some limitation regarding the funding, because this research also actually granted by the BIMA. If you know, it's like the funding from our Ministry of Education, but we have to very careful to uh how can I say, to choose which one should I analyze, because we analyze better because of the funding. So we actually planned to analyze this as well, the essential aluminum, but we finally eliminated because of that finding and also our laboratory limitation. Thank you.
Thank you so much, Ms. Limartaida. To Dr. Mohamed Nurkalis.
There's a question. I'm just asking if it's the answer.
To Mr. Mohamed, to Dr. Mohamed Nurkalis, is the answer from Ms. Limartaida answering your question? Is it enough?
Enough.
Enough. Okay, thank you so much. And for our on-site participants, we have one more question for Ms. Limartaida.
Okay, thank you so much. Thank you so much for the presenters. Very good information you provided us. I have a question for the third participant, Mr. Ahmed. Thank you so much for giving us so much very good information. I am just curious about the presentation that you showed that cactus powder near the population of the state, right? I am just curious that cactus powder has effect on the health of the bacteria or kill the bacteria, just coagulate and provide a while. As you know that we can settle the bacteria. They collected as the cells of the water, right? Does the cactus powder also kill the bacteria? Did you check such type of bacteria?
Thanks for your question. It's bacteria will not be killed, just make the absorption, like catalyst powder will collect all bacteria around them. And you can take the clean water under the surface, like with 3 centimeters or 5 centimeters maximum, and you can get the clean water of it. Like it won't affect bacteria. We won't get like all the acetate and the surface will be removed, not be used. We can take the middle layer only.
Thank you so much for answering. I just was curious that if the cactus powder is affecting on their immunity or maybe kill the bacteria, it can be helpful for the health of the users.
That's what it is.
Oh, okay. Thank you so much. Yeah.
Okay, sorry for Ms. Limartaida. The question was for Mr. Ahmed, so it wasn't for you. I'm really sorry for the confusion.
Okay, it's okay.
Okay. Now moving on to Mr. Mohamed Gaukhan Tamalaki. Is there any question for Mr. Mohamed? Please share.
Yeah, because my student, maybe I will ask him. Yes, yes.
Don't want to ask about soon.
Yeah. Okay. Halo, Gaukhan, you
Yes,
hear
Prof.
me? Yeah.
Yes, Prof.
Okay. Maybe would you please to explain about the uh, how do you make sulfur activated biochar? Maybe you can explain more detail. Okay.
Okay, Prof. Uh, thank you very much for your question, Prof. Maybe uh, in my experience research, uh, uh, I'm make biochar, but biochar biochar original biochar with ketapang. But for now, in this is my thesis research. This is my thesis research. For now, I'm going to develop the biochar to make biochar modified. Biochar modified is very. I still believe this biochar is very strong to absorption heavy metal in soil or in water because this biochar have a sulfur very very strong to absorption heavy metal. And I'm combine my my study my background study in bachelor is chemical engineer and soil science to make this and biochar. Uh, I make the biochar with my design reactor. I have a design reactor biochar. Uh, the mechanism with biochar mechanism use biochar to reaction with dry gas as sulfur dioxide. And this biochar, I believe, can be more strong to absorption the heavy metal. I believe this because my literature about this biochar it is uh, very uh, I don't know how you can say but my literature in this part this study uh, I have experience from this study. Yeah, okay. Thank you very much.
Okay. Thank you.
Thank you so much, Mr. Mohamed Gaukhan. Now we are going to move on to the photo session. To all participants and our speakers, could you please open your camera?
Shannon, open.
Okay. Miss Sophia Husna from University from UNESA, could you please open your camera because we are going to do a photo session.
Professor open to react. Last.
Okay, we are going to do a photo session. Okay, thank you so much for our presenters and participants for a productive and engaging discussion. As much as we would like to accommodate all of your questions, we must conclude the session to stay on schedule. Please join me in thanking our speakers once again for their valuable contributions and excellent presentations. This concludes the breakout session under the track of soil. Thank you, everyone. We kindly invited all participants to return to the main room for the symposium closing program. And that concludes our presentation for today. Please move to the concluded main room. Thank you.
Thank you, Professor. We'll just wait for everyone. That's the end for the soils. Congratulations. I will just wait for the others to come back here for the closing. So I will place him in and go. Sustainable. I moved him. Okay.